Let's talk about the domain of logarithmic functions. Remember that logs are the inverse of exponential functions. We know the domain and range of log functions. The domain of an exponential function equals the range of a log function. What was the domain of an exponential function? Do you remember? It's the set of all real numbers. So the range of our log function is the set of all real numbers. What about the range of our exponential function? We had that horizontal asymptote. The range of an exponential function is the domain of a log function. And those asymptotes come into play here from 0 to infinity. That means that the domain of my log function has to be greater than 0. The domain of the log function has to be greater than 0. When we're looking at the domain of a log function, we're looking specifically at the argument. The argument is the stuff inside the brackets that the log is applied to, and the argument has to be greater than 0. Not equal to 0, just greater than 0. So the first thing we have to be able to do is find the argument of a log function. If we look at the f of x here, we see that this is the argument, everything inside the brackets. Then for the domain, I have to find the argument greater than 0. X has to be greater than -3. So in my domain then, -3 to infinity. What's the argument for the g of x? Everything inside the brackets. Write the domain for the g of x in interval notation. Did you remember when you were dividing by a negative to change the direction of the sign? X has to be less than 7/2. Now look at the h of x. What's the argument here? It's only x. There's no bracket around x plus 3. In fact, if we were to have to evaluate this, we would have to find log base 2 of x and then add 3. The argument here is only x, which has to be greater than 0. Find the domain for the m of x. So we see the domain here, -½ to infinity.